Okay, here we go. Today is the review day for the quiz tomorrow. Obviously, since I'm putting this out during summer period, we'll have to make arrangements out the quiz. Right now, I'm thinking we'll probably have you guys take this during Friday. I have fourth and seventh period open, so those two might be the periods that I look to do that. We may be able to have you take it during the class period that you're assigned, and we'll talk about that and see where we're at with that. So, just going through this quick review. So, the property is logarithms. So if I have log base x of 4 plus log base x of 9, well, since we're adding there, we'll want to multiply those two logs. And then for the next one, log base x of 4 minus log base x of 9. So what I'll do with this one is I'll end up going with log base x of 4 divided by 9. Okay, so subtraction is up to be division. And then this is going to be, let's go with 3 log base x of, I don't know, let's go 7. So what this is this becomes, now this 3 ends up to be the exponent. And there we go with that. And then the last one actually, I'm just called the change of base. So log base 3 of 7 is equal to log base 7 divided by log base 3. So those are our properties that we use with this and what we've been using. The other thing that I really want to stress with this is we have to be able to go from logarithmic form to exponential and from exponential to logarithmic. We have to be able to switch those very quickly and very seamlessly. So those are really important with this. So just to highlight that, so here's what we're going to do with this one. So here we start off with this logarithmic. And as I look at this, I'm going to try to hopefully see a relationship with 81 and 3. So this is log base 3. 81 is 3 times 3 is 9 times 3 more 27 times 3 is 81. So this is 3 to the fourth power. Well, if I can get the log, the base, and the exponent, the base to the exponent to be the same, then I'm going to be able to tell what that answer is. And sorry, so if I have 4, an exponent of 4 to another power, that's 4 to the 16th. Now these two 3's match up. So what ends up happening is this answer is just the exponent. So there we go with that one. Now, if you didn't see it that way, let's say that I did this a little differently. I see this 4 coming out here, base 3 of 81. Okay, now I still have to see log base 3 of 3 to the fourth. Well, these go away, so it ends up to be 4 times 4, 16, same answer, just a different way. All right, so now this one, we left it logarithmic, but we found we saw the relationship between the base of the log and the base of the exponent. Now this problem, well, in my opinion, when I first see this, I think I need to put the 2 out in front. And unfortunately, when I do this, it doesn't gain me anything. So what I end up doing is saying, that's not it. So I'm going to go back, and I see this, and this is a base 10. So 10 to the fourth, change this to exponential, is equal to 2x plus 4 to the second power. This is 10,000 is equal to 2x plus 4 to the second power. Now to get rid of that second power, I take the square root. And so what I end up with is 100 plus or minus is equal to 2x plus 4. So 100 minus 4 is equal to 2x. 96 equals 2x. X equals, I believe that's 48. And then negative 100 minus 4 is equal to 2x. Negative 104 is equal to 2x. X is 52 negative. Okay, So now if I were to put this 52 in here for the x, this ends up to be negative. This one doesn't work. It's extraneous answer. All right, let's look at this one. Okay, logarithmics. To be able to solve these things, this is just generally all the way true. We want to isolate this. So if I have 3, let's see, if I have 3 e to the 9th is equal to 7. Let's make this 72. I need to divide everything by 3 to get rid of that. And let's see here, if I divide that, that's 24. So that's what it means by isolate. Get this e by itself. If this were add, I would subtract that from both sides and be able to do that. Then I need to start doing the evaluating and solving this. So then from here, I would end up, well, it's someplace in here. This example, I'd have to have an x in there. So I could do that from there. Natural log and logarithm are basically the same. I'm going to use the natural log has the same exact properties as logarithms. So if I see add, I know that I need to multiply. If I see subtract, I know I need to divide. But natural log uses e as its base as opposed to write it exponentially. And I would say natural logs, I use natural logs when I see e. Every other time I use logs. Now, let's look at this particular problem. This particular problem is very similar. So log base 2, they're both the same base. It has add in between there. So I'm going to take and I'm going to multiply these two. So there's this. Okay, now I'm stuck. So what I'm going to do is, if I get stuck with these, my general next step is to write these exponentially. So 2 to the third is equal to x squared minus 2x. Now my old habits come in. Anytime I see x squared, I think I need to solve this, and I need to set it equal to 0 and be able to factor. So this is 8, so I'm going to subtract 8 from both sides. So I get x squared minus 2x minus 8 equals 0. And now I factor this. So minus 4 plus 2, x is 4, x equals negative 2. Now if I put this negative 2 in here for this, that's a negative value. I can't have that, so that's an extraneous solution. So there we go. That's the review for today. The assignment is right there on Canvas. Okay. Now remember, you need to have all these assignments completed so that when you get done with this chapter, we can start to submit things and get a test replacement. All right. And this is the last of the assignments that will count towards that. You get this one done and turned in. Everyone prior to this needs to be done and turned in so that you can get credit for those things. All right. That should do it for today.